Okay, so thank you for allowing me to present here. This might seem like a big change and jump from what we heard so far today, both in methodology, objectives, and everything, but yeah, hopefully it's interesting for you. So here I'm going to present. I'm a PhD student at the Max Planck Institute for Demographic Research, and I'm going to present one of my projects that I'm working on with Ugo Filippo Vasellini, Giancarlo Camarda, Fanny Jansen, and Emilio Sagani. And this work started from the objective of estimating education-specific mortality rates for Mexico. And we wanted to do this by combining two different data sources. And I'll explain to you what we've done so far and why do we need to combine these two data sources. This work is also preliminary so far, so I would appreciate any comments, suggestions, and anything you have. So what are the two data sources that we have for Mexico? So on one side, we have the vital registration and the population census, and on the other, we have the Mexican Health and Aging Study. So the vital registration and the population census is the normal annual administrative register, and the census, we have census and inter-census surveys that are conducted every 5 years. And on the other side, we have the Mexican Health and Aging Study, which is the longitudinal survey, very similar to HRS. And in Mexico, it has been conducted since 2001, and it has 6 follow-up waves in the years that I show here. And in years 2012, 18, and 24, it's where they added new sample to the survey to fill out the younger cohorts to always have population that's representative for adults 50 years and older in Mexico. Just to give you a rough idea of the sample size of the survey, in 2021, there were around 50,000 participants. So this survey is representative at the national level at urban and rural disaggregation. So this is the Alexis diagram of the Mexican Health and Aging Study. This is just to give you a rough idea of the data that we have to do longitudinal analysis and to estimate mortality from it. So we have here a sample of 1,000 random individuals from the survey. You can see like a basic survival trajectory. The pink dots are the deaths, and the gray ones are the data that is censored. And here I just want to point out how in 2012, for example, new younger cohorts are added to the survey and so forth over time. And this will become relevant in a while. What are the advantages of each of these data sources? So the vital registration, its main advantage is that it covers, or at least it aims to cover, the entire population, and we have it for all age groups. On the other side, the Mexican Health and Aging Study, as we know, it covers not just mortality, but it has a lot of information on most variables, any variable that you might want, basically, for older populations. And the Mexican one, compared to other similar surveys, it actually has high response and follow-up rates. What are the disadvantages, and thus why do we need why they need to combine them? So the vital registration and the population census, it has several data quality issues. So it has under registration, not all deaths are registered. We have age misreporting. On these two first issues, we have fairly good knowledge and we know how to correct them. But on top of that, because we want mortality by education, we have education misreporting. So what happens is that in the death certificates, when the death happens, someone else reports the education of the deceased, and this might be a family member, but maybe it's not a family member, and this person may or may not know the actual education level of the deceased. So we have some misreporting here. And the problem is that we cannot measure this education misreporting because we don't have an additional data source which we can link to verify what was reported. And then because we're using the vital registration as the numerator for mortality rates and the census as the denominator, we have what is called the numerator-denominator bias, and it arises because we're using two different data sources to estimate these mortality rates. And these usually can be seen in crossovers in mortality rates. So you would have unlike crossovers in mortality at higher ages between education groups. For the Mexican Health and Aging Study, the disadvantages is the sample size. It's a survey, so we have a limited sample size. we have survey attrition, so we lose participants over time. And also this has been shown that it's related to our variables of interest. So it's related to sex, it's related to age, and it's related to education. So we need to correct for these variables to have an appropriate mortality estimate. And also we have these irregular interwave periods. So the big gap we have between 2001 and 2012, that no sample was added in between. It's detrimental for us to have mortality estimates over time. And plus, we can also have education misreporting. So interviewers do not verify the education level, right? So they're better trained. We can assume that the data is better, but still there's a possibility. So what we know so far about education, mortality by education in Mexico. So previous studies have estimated it from each of these data sources separately. When looking at the Mexican health and aging studies have found basically for men, no educational gradient, and even in some cases, a reverse educational gradient, which means that lower educated individuals have higher life expectancy or lower mortality than high educated individuals for men. And then for women, it has been found a slight gradient in mortality, but only for women with 7+ years of education and with higher wealth. These have been found to have lower mortality levels. On the other side, when we look at vital registration and census estimates, we find for more recent years in 2018 an education gradient when using 3 groups, but only for partial life expectancy from 30 to 75 years. And when we look for life expectancy from 30 years and plus, we find a partial life expectancy, which is to say, yes, there's a difference between the lower and the highest educated group, but those groups that fall in the middle, they're crossing over between them. So in summary, we don't have estimates are not consistent across data sources. So we wanted to combine them to find a single estimate. So what we found so far. So this here, you're seeing the partial life expectancy between ages 60 and 85, estimated from this data source that we're calling CONAPO, which are the official population estimates. These are the estimates for the total population by sex. And these have been corrected for under registration and age misreporting. So these would be what we call the true mortality rates. When we look at the vital statistics, we see some unlikely patterns. So we see for males, for example, we have that those with primary education, which is between 1 and 6 years of education, have actually a lower life expectancy than those with no education for males. So this is a sign that something is, I don't want to say wrong, but something is strange with the data, because we would expect that the no educated males would have a lower life expectancy with those with at least 1 year of education. For women, we do see that gradient, but it's almost non-existent. So this points out that the life expectancy, that mortality estimates by education from the vital statistics with no correction have some problems. When we look at the Mexican health and aging studies, so this is the estimates from the Mexican health and aging studies, we're estimating mortality using the waves from 2001 and 2003 for the first time point in 2002, and then the waves 2012 and 15 for the points used in 2013. And here we see, I'm going to start for males. So we see, in this case, the no educated men have lower life expectancy, which is what we would expect to see. And the points in 2002, this is in line with what others have found. There's not the real gradient, right? So the secondary or higher educated men, they have a lower life expectancy with those with primary, but for the second time point, this sort of corrects itself, and it's getting to the pattern that we would expect. And for women, we have the pattern. So those with higher education have higher life expectancy, and this is a gradient. When we put both together, we see that also the Mexican health and aging study in general has lower mortality levels, which in this graph, it translates into having higher life expectancy. So Because even in the Mexican Health and Aging study, we found for the first time period a gradient that was not what we would expect, and we're assuming that the Mexican Health and Aging study has a good quality for the education reporting, we went to what we're calling a tangent, and we started to question the role of education as a proxy for socioeconomic status for the Mexican population, especially the older population, because we have a lot of very few population with high education, and we're not seeing the gradients we expect. So here what you're seeing is just a comparison of the 3 education groups, their composition by 2 other socioeconomic status variable proxies. On the left-hand side, you see the availability of toilet in the household at age 10, and on the right-hand side of wealth. So we have socioeconomic status in childhood and socioeconomic status in older age. And what I would like to point out here is that the no education and the primary one, they both have high proportion of people who didn't have a toilet in the household, and they actually have very similar composition. So what I want to point out here is that we're using these education groups, but they're actually quite heterogeneous inside them. So this might be an explanation of why, when we look at 2002 in the MHAS, this might be better. We don't see the patterns that we would expect. So just to conclude, what we have found so far is that the MHAS has a lower mortality levels than the official population estimates. This is common in longitudinal surveys and expected. Both data sources have different educational gradients, but this is most likely because of quality of education reporting in the vital statistics. And the MHAS estimates suggest an increase in inequality in mortality by education level, especially among men. And what are our next steps to finally combine the data sources? So we're trying to fit different models to estimate mortality by education at different time points in the Mexican Health and Aging study. So I showed you only 2 time points, but ideally we would like to have more so that we can get a time trend. And then we would like to apply the relative mortality differentials that we estimate from the MHAS and try to correct the vital registration estimates. But this is what we have for the next steps. And thank you so much for your attention.